In this video we're going to be having a look at calcium carbonate and we're also going to look at limestone. So limestone has loads and loads of uses. It's an example of a sedimentary rock. Now the way we get it is through quarrying it. So we use explosives to break away the limestone and cause it to come off in pieces, and then it's cut or crushed to make it useful, and then it's transported to the customers. Now you need to know some advantages and disadvantages of quarrying this limestone. So some advantages are that there is a massive commercial need for it. It creates jobs for local people, and it also helps the UK economy because it can be exported abroad because it is quite a precious, wanted material. Disadvantages though, dusty and noisy, so this could affect wildlife, it could affect local people as well and affect their quality of life. It also could damage tourist industry because they're often found in attractive places, and it also can destroy the landscape, and it means that that land is not going to be used for farming. But on the plus side, quarry owners often restore the land back to what it used to be or turn it into a nature reserve. Now as it is, it can be useful, but also we can do some magical chemistry with it and create some brand new compounds that are going to have lots of uses as well. So for example, we can create concrete, cement, glass, and also use it in making steel and iron. So first thing I want us to have a quick look at is something called thermal decomposition. So when you look at decomposition, you think of breaking down. When you see thermal, you should think heat. So this is breaking something down using heat. And this is what happens when we heat up limestone, or the main compound that is in limestone, calcium carbonate. So when we heat this calcium carbonate, it produces two new products. We get calcium oxide and also carbon dioxide. And this is used in the manufacture of cement and glass. So when we're making cement, you heat it with powdered clay. And cement is used in mortar, which is used by bricklayers to hold bricks together in walls. Concrete is actually a mixture of cement with sand, gravel and water, and this is used in the construction of buildings and bridges. Glass is when we heat it, and by it I mean the limestone, with sand and sodium carbonate. When you do this, you get liquid glass being made, and it will then cool, and you can form hardened glass with it and use it to make windows and things like that. So that was looking at taking the thermal decomposition and actually creating something useful with the products. For people who are doing higher, you need to know this equation in its symbol form as well. So the formula for calcium carbonate is CaCO3, and that is a solid when we're using it. That produces CaO, which is a solid, and carbon dioxide, which is a gas. Now we can actually take this further and produce something called lime water. So to produce lime water, we take calcium oxide, which we've made under the thermal decomposition, and add it to water. When we do this, we get calcium hydroxide. Again, higher you need to know the symbol equation, so that's CaO again, and that's in the solid form. Add it to water, H2O, which is liquid, and you get Ca bracket OH bracket 2 in a solid form. And this calcium hydroxide is called lime water, and you can use this lime water to test for the presence of carbon dioxide, because it goes from a colourless liquid in the form of calcium hydroxide to a milky liquid. And the reason for this can be seen when you look at the chemical reaction. Calcium hydroxide, we're testing for carbon dioxide, so that's going to be the reactant alongside calcium hydroxide. So carbon dioxide. You produce calcium carbonate and water. So that production of calcium carbonate is the reason why you get that milky appearance to it. So if we have a look at this, again, higher you need to know the symbol equation. This is CaOH2, but in an aqueous solution. Remember, aqueous was basically dissolved in water. Add it to carbon dioxide gas, so that might be you just blowing into it because you breathe out carbon dioxide. You get CaCO3 as a solid and water, which is H2O. Now, just a quick thing of the fact that acids can be neutralised by an alkali in neutralisation. You can watch that video to find out a bit more about that. Calcium carbonate, calcium oxide and calcium hydroxide, so all three things here that we've made, can actually neutralise acids. So farmers use this. They might spray any of these three things onto their fields, and that is going to neutralise any acidic soil, but also it's used in power stations. So when we burn coal, you actually are giving off some sulphur. If that's added to oxygen, you get sulfur dioxide being produced. In the same way you could get nitrogen oxides being produced, and these are both acidic. And they could produce acid rain if they escape from the chimneys. So what we do is we kind of spray them with wet calcium carbonate. So we spray these at our waste gases. This is going to neutralise the acidic gases and therefore reduce the harmful emissions and reduce any acid rain. Now that was a very quick run through of calcium carbonate. I suggest you go away and do a few activities now. Maybe try writing those equations by yourself and then check them, and also doing some past exam questions. Thank you very much for watching that video, and good luck in your exam.